Photon, also known as light quantum, is a minute energy packet of electromagnetic radiation. The idea of photon arose in 1905 from Albert Einstein's description of photoelectric effect, in which he suggested the presence of discrete energy packets during the transmission of light. Photons are massless and they move at the speed of light. Each photon has momentum, energy, and speed, which is the speed of light. Photons are electrically neutral and are not deflected by electric and magnetic fields. Photons can be destroyed or created when radiation is absorbed or emitted, respectively. The total momentum and total energy are conserved in a photon particle collision. All photons of light of a particular frequency and wavelength have the same energy. Photons have zero resting mass. There are multiple ways to produce photons, but they utilize the same mechanism inside an atom. The mechanism concerns energizing the electrons orbiting each atom's nucleus. Typically, an electron has a predetermined orbit that it inhabits. But if we energize an atom, we can reposition its electron to higher orbitals. A photon is produced when an electron in a higher than normal orbit falls back to its regular orbit. The electron emits a photon with particular characteristics during its fall from high to normal energy. The photon harbors a frequency that precisely corresponds to the distance the electron falls. We are aware of the fact that mass is just another form of energy from Einstein's special relativity. A photon has momentum proportional to its energy even though it does not have mass. The photon momentum is derived from its energy and frequency as described by the Planck-Einstein relation E is equals to hf. But since a photon is always moving at the speed of light, it can't have any mass due to Einstein's equation. But obviously, the photon nonetheless has to have energy. Otherwise, it won't produce the photoelectric effect. The natural judgment then is that all of the photon's energy is in form of motion. This ultimately leads to the fact that if a photon moves and has energy, it must likewise have momentum. A photon is a type of elementary particle that primarily acts as a carrier of energy. It's not energy itself, that's why different photons carry different amount of energy and accordingly their wavelength differs. And the law of conservation of energy does not apply to them as they can be created and be destroyed. The photon structure function in quantum field theory describes the quark content of the photon. While the photon is a massless boson, through certain processes its energy can be converted into the mass of massive fermions. A photon doesn't lose energy unless it collides with a particle. A faraway photon appears redshifted not because it traveled a long distance from the source to the observer, rather it is a proof of the source and the observer receding from each other. So for low energy photons to exist in the universe, a high energy photon will have to be absorbed by an electron and then emitted as more number of low energy photons. Subscribe.